Well, good morning, everyone. It is 10 o'clock and we will get going here with our webinar, our workshop for today. Um, thank you. Good morning, everyone, and welcome to the Living Lab Club virtual workshop titled Cropping Systems, Implementing Regenerative Practices. My name is Dan Cox, and I'm the project manager for Manitoba Association of Watersheds. For anyone just hearing the name Manitoba Association of Watersheds, or MAW, for the first time, we are a nonprofit association that supports Manitoba's 14 watershed districts in their efforts to protect Manitoba's soil, water, habitat, and climate. Before proceeding any further, I would like to acknowledge that I am hosting this virtual workshop from my office in Winnipeg, Manitoba, which is located within Treaty 1 territory, the traditional lands of the Anishinaabe, Cree, Oji-Cree, Dene, and Dakota, and is the birthplace of the Métis Nation and the heart of the Métis Nation homeland. Over the next 2 weeks, MAW will be hosting 4 Living Lab Club virtual workshops covering regenerative agricultural principles, cover cropping, and the Living Lab Eastern Prairies experience. These workshops are being funded through the Living Lab Eastern Prairies project, which is a 4-year project with Agriculture and Agri-Food Canada that provides funding for farmers, researchers, and various partners, such as watershed districts, to work hand in hand on farms, developing novel tools and techniques that are tailored to local environments and needs. For more information on the Living Lab Eastern Prairies project, please visit the Manitoba Association of Watersheds website and the Agriculture and Agri-Food Living Laboratories Initiative website for all the details on research projects and the projects going on at the districts. Before I introduce our moderators today for today's workshops, I would like to cover 2 housekeeping items. These Living Lab Club virtual workshops are being recorded and will be posted on the Living Lab Eastern Prairies websites and social media for further viewing. And 2, the Q&A function of this webinar is active, so I strongly encourage people to provide any questions you have using the Q&A button at the bottom of your screen, and they will be answered in the Q&A box by the panelists or during the Q&A sessions of today's presentations. I would now like to introduce the 2 gentlemen that will be moderating today's workshop. First, Mr. Michael Thiele from Shoal Lake, Manitoba. Michael was born and raised in Dauphin, Manitoba on a small mixed family farm. From there, Michael went on to study plant science in the Faculty of Agriculture at the University of Manitoba. Over the past 30 years, Michael has worked in conservation and agriculture with a focus on resource management and soil, water, wildlife, and growing food. Second, Mr. Blaine Hjertaas from Southeast Saskatchewan, near the town of Redvers. Blaine has been farming for 48 years, 25 of which farming regeneratively. Blaine has taken his soil from 2% to 8% organic matter over the past 20 years. For the past 10 years, Blaine has been doing consulting work in the area of regenerative agriculture. So now I will pass it off to Michael and Blaine for today's workshop.
Dan. Share my screen. How's that?
Working. Good.
Good. All right.
Yeah.
Okay, I just put this up real quick. A lot of what we're talking about here today, you can find more information on understandingag.com. Blaine and I do a little bit of work with Understanding Ag, and a lot of it is trying to help producers have a deeper understanding. And, only through that deeper understanding can we make change together. Yeah, so today, working with the Living Labs and the Manitoba watersheds, we're going to talk about regenerative principles in cropping systems. And just a quick introduction. Dan was telling me we probably got about 100 producers and watershed staff and others on the call today. So that's a great turnout. Pretty much 2 years to the day ago, Gabe Brown and Ray Archuleta were up in Manitoba, and the 3 of us did 4 workshops across Manitoba, up in Shoal Lake, Swan Lake, Morden, and Rosa. And we had over 300 producers in those 4 workshops. It was incredible. And so I think back to that, and that seems like a lifetime ago kind of that was just right when COVID was just a whisper. So today there's myself and Blaine. Blaine's over in Saskatchewan, farmed down by Redvers. He's now living the life at Kenosi on the lake there and working with me on a number of projects. He's also a holistic certified educator. And then we have two producers. They're the ones you really want to hear from. So we'll get to that as soon as possible. Darren Maddess down at Deloraine and Alex Boersch at Elie. And please type your questions into the Q&A and we'll get to them in the order that they're entered in. And we should have lots of time for questions and discussion. So here's the 6 principles of soil health or regenerative agriculture. And Blaine and I are just going to talk real quick about these 6 principles. I just mentioned, when we say soil health, I really like that term. The reason I like it is the word health. It makes you realize that soil is alive. We only give the designation of health to things that are living. And it helps us to understand that soil is a living kind of superorganism, and it can be healthy or unhealthy. So I just want to talk real quick. We talk about these regenerative principles, but what is a principle? And this was something I had to kind of stop and kind of think about back when I started to hear this term, regenerative principle. And basically, a principle is just sort of the most fundamental truth that we know based on our best understanding. And in this case, our best understanding comes from science, and science is simply observation and experiment. It's nothing more than that. We try to politicize it and all that, but it's simply observing the world. And that's one of the things we really focus on, Blaine and I, when we're working with producers, is to try to be as observant as possible, to sort of observe how nature works. And really what we're talking about is biology. And biology is simply the study of life. And you'll notice I have a capital L on life. So that's capital L life. And so that's organisms, but also it's sort of the larger life of the planet, of the biosphere. So, when people ask me, what do I think regenerative ag is? What's the definition of regenerative ag? People will say, well, you go on Google regenerative ag and you'll find 100 different definitions. And you're right, there are a number of, but I think they fundamentally come down to one thing, and it's basically the rules of nature, and it's sort of understanding that we can apply those rules of nature to agriculture, and that's pretty cool when we can do that well. And it's to understand that things work in systems, that they're interconnected, and that this regenerative idea kind of represents a fundamental shift in how we relate with nature. So with that, I'm going to pass it over to Blaine, and he's going to talk about the first few principles.
Morning, everyone. Hear me, Michael?
Yep.
Okay. Thank you, Dan, and the Manitoba Association of Watersheds for putting this particular webinar on. I think it's wonderful to have a lot of producers willing to come and learn about soil health principles. I think the key from the work that Michael and I do, the key is education. If we want to change people's minds, they have to truly understand why you have to change. So that's kind of what we're all about is this Understanding Ag company that we work for. And as Michael said, I encourage you to take a look at the website. There's a phenomenal pile of resources on Understanding Ag's website. It is the world's largest regenerative consulting company, and it goes right across the world. So take a look at that. So when we look at just go ahead one slide there, Michael. When we look at the soil health principles, they're something that you need to kind of get into your head. They're nature's laws, but we need to have them so that when we're contemplating what we're going to do on a particular field, we have to kind of go through a little checklist in our brains and say, well, are we going to get this one? Are we going to do this one? Are we going to do this one? Maybe, the way farming is, we can't do all of those every time. There's no way. So, sometimes we say, well, we got to do this. We're going to go backwards a step in soil health, but we'll do this and this later in the season or next year or whatever to minimize the effects. And so as you get better at this, when we start out, we're all crawling, eventually you start to pick yourself up and start to walk a little bit. And maybe in a few years, you're starting to trot along. And the more you practice this, the better you will get at it. And so the key is to make sure you got this firmly entrenched into your brain if you want to become regenerative, and then start working hard at it. And I guess the people that we work with where we see the most success are those people that spend a lot of time in their fields. It's directly proportional. The success, as we measure it, of regeneration is directly proportional to how many steps or farmer steps there is in that field. So as I said, these are natural laws. It isn't some PhD somewhere invented these things. So we're just going to go through these, explain the why we want to do these things, and then we'll turn it over to the farmers that are actually doing it. So let's go to the next one there. The context, Michael. So when we talk about context, this is the one that's man-made, and I guess so we put it at the top. And it's really important to understand what your context is. As an example, if I farmed at Prince Albert, Saskatchewan, and I really love bananas, probably I'm out of context. I don't think they're going to work in Prince Albert. So that's just a real simple, dumb example to get what I'm talking about. So there's four real parts to context. There's the ecological part, and that depends where your farm is situated. Are you right along the border? Are you up against the tree line? Is your land low? Like, is it prone to flooding? Is it heavy? Is it light? Is it rocky? All of those things you cannot change. That's just the way it is. So you need to, take that into account. That's part of your context when you're designing systems that become more regenerative. You need to be thinking about, well, what are my limitations? Can I do that? The second part of the context is financial. So if you happen to have $1 million and money isn't that big a deal to you, you can probably do more than somebody that's, the bank's after them every day and they're running on lines of credit and all these things. So, that's an important part when you're trying to figure out if you want to become regenerative. It makes a huge difference in what you can do depending on your financial situation. The third one is societal. And we see this often with fathers and sons, that the son will say, boy, this really makes a lot of sense. And the dad says, what kind of crap is that, buddy? We're not doing that in my farm. And so that causes huge issues. Sometimes it can be peer pressure from your neighbors that, if you're kind of the only guy in the community that's starting to try something different, sometimes the coffee shop can get kind of brutal. So these are all things that you need to be aware of that can limit you. It can constrain some of the things that you may want to do. And the last one then is spiritual. And I think we all have different beliefs, and it does make a difference when you're thinking about how you want to do things on your farm. So that's the first, and that's the man-made one, I guess. So now let's go into the principles themselves, Michael. And these particular principles have no numbers. They're in no particular order, and they're in no importance. Like, not armor isn't more important than another one. They're all equally important. And so we're just going to share them in mixed order here. So the point is that it doesn't matter. Each one is equally important. So the concept of armor is litter, as some people call it. I like to use the analogy of skin. So if I took my arm and I stuck it into a fire for a minute and left it in there as long as I could stand it and yanked it out, probably the doctor would end up cutting it off, because that skin on my arm is absolutely critical for the success of me as an organism. And so skin does a lot of useful roles. It keeps me warm, it keeps me cool, it keeps moisture in, it keeps pathogens out, all sorts of different functions that skin does. And so the skin on the soil is exactly the same. And you can see in that picture right there that you do not see bare dirt. And yet when we travel around western or the eastern prairies, we see lots and lots of bare dirt. And so that has huge consequences for how the system functions. If we think about a raindrop coming down and hitting the bare surface, we've all been out in a storm where rain hitting our faces actually stings, it hurts, it's coming down so hard. Well, you can imagine what that's doing to bare soil particles and the impact that has on soil health. If you start to make those soil particles bounce around from raindrops hitting, it tends to puddle it, it seals the soil off so that the water runs instead of enters. Whereas when you have litter or armor on there like that, it's just like a sponge. That armor keeps everything nice and moist. The water doesn't directly hit the soil. So it's a much better system. So anything that we can do then as farmers, when we're out there doing what we do, we have to be thinking about how can I keep that armor on my surface. Let's go to the next picture, Michael. So this just was a picture I took last summer. So the air temperature that day, I think it was the 22nd of June, I took this picture. The air temperature was 25 degrees. It was a wonderful year last year for demonstrating this. This is a digital thermometer, or laser thermometer, I should say. It's just taking a picture of the ground temperature. So on the bottom left-hand side is bare soil. So the soil temperature was 55.1 degrees C with the air temperature of 25. The next picture up at the top right is the temperature of the litter. So the litter temperature itself on the surface was 52, so not a whole lot of difference. But then I scraped that litter back just with my fingers. I just got back to the bare earth and took a temperature, and under that litter it was 34 degrees. So that's a pretty phenomenal difference from 55 to 34. So that's over 20 degrees C difference. And so you think about what's happening to the moisture in the surface. We all know it was extremely dry last year, but I can guarantee that the field on the left, if it all would have been like that, it would have had considerably less moisture than the field on the right. So, moisture is usually a limiting factor, part of the growing season every year. And so if we can keep our soils covered in litter, that makes a huge difference to how well we retain moisture. Okay, the next one. So the next principle then is animal incorporation. And so when we think about, excuse me, when we think about nature and how these soils that we farm here in the prairies, they were all formed with animals. When the glaciers receded 9,000 years ago or whatever and melted away, there was this huge amount of glacial till left, which we call soil today, that was 0% organic matter. Grass started to grow on it, bison started to graze it, and lo and behold, 9,000 years later, roughly 150 years ago, our forefathers came here and started to farm it, and it was 12-14% organic matter, just depending on where you were. So that 10,000 or 9,000 years of animal incorporation created an awful lot of organic matter. And so we've removed the animals largely from our operations. And regenerative agriculture isn't saying to you that every one of you needs to get cows back on your land. That's not what the principle is saying. But maybe there's a way once every 2 years, once every 3 years, you can grow a cover crop or something like that, and you can get neighbors' cows to come onto your field for a while and graze it off. It'll benefit both your soil health and your cow neighbors' grass management. So what do these animals do? So when animals graze, they actually tug, they pull the plant, they wrap their tongue around it and give it a yank. And that has a tremendous stimulation to the life below the soil. So it actually breaks part of the plant, which leaks an awful lot of sugar into the soil, which just creates a frenzy of regrowth. And so that can't happen with any other, there's no other way we know of to do that. So we get this tremendous regrowth after a grazing, assuming we graze properly. And that's, by grazing properly, I mean we're putting cows on a piece of land for 1 or 2, 3 days, and then they're moving. Also, microorganisms, we know from some of the work we've been doing on the farms in the eastern prairies, that microorganisms are our shortest, one of the weakest links in our agricultural system. We just don't have enough microorganisms because of the way we've been farming the last 150 years. So cows That rumen there on the left-hand side is one fantastic factory for microorganisms. So every time she consumes some forage and poops it out, you're getting microorganisms spread across your field. Also, that cow, the hair on the side of her, she has a huge amount of microorganisms that she's carrying around. And if you watch cows, you can see dust almost coming off them. They're continually moving microorganisms from one spot to another. And you can't make litter or dead plant material recycle any faster than through an animal. If you leave it laying on the ground, it may take a year for that plant material to recycle. You can run it through a cow and you can recycle it in 2.5 to 3 days. Next picture, Michael. So this picture just illustrates what grazing does. So I'm standing right on top of a fence here. You can kind of see the wire right directly below the bottom of the picture. This picture was taken on the 16th of July. And you can see on the right-hand side, that's pretty nice. It's vibrant, or wouldn't say vibrant, but it is definitely green. It's photosynthesizing. It's sending sugar down through the roots into the microorganisms. Good stuff is happening there. Whereas on the left-hand side, it hasn't been grazed yet. Those plants are fully mature and there's basically no photosynthesis happening there anymore. It's just like when a canola plant or a wheat plant gets ripe, that is basically just sitting there. It's not doing anything. So I could take a herd of cows now and run across on the left-hand side, and I could recreate what's on the right-hand side very quickly just by grazing it. So by proper grazing management, we can extend our growing season much longer than what a plant would naturally do. Most plants will come mature in 40 or 50 or 60 days. And by chopping them off, we can get them to regrow again. And every time they regrow, we get this huge release of sugar, which stimulates the microbes, which does all sorts of good things for our soil health. Okay, I think that's it for me, Michael. Your go.
Thank you. Dan, is the Q&A working? I don't see any questions yet, so I'm just sort of wondering, maybe if someone could post something into the Q&A just as a test so we can see if it's functioning.
There you go.
Oh, there we go.
Going,
right.
It's going.
Okay, good. Yep, all right. Or the chat, but let's try to use the Q&A if we can. All right, cool, good, thank you. Okay, so not seeing any questions. We'll continue. Okay, so the next principle is keeping it green. And basically what we're talking about here is just to keep a green plant and a living root growing as long as possible through the growing season. And you may wonder, well, why would that be? And the simple answer is this, and there's a lot here, so let's not look at all of it. Let's just look at the top left-hand corner where you see the sun, and the sun is shining down on a bunch of green plants, and there's CO2 from the atmosphere, and there's water from the soil, and then the miracle of photosynthesis, solar energy is converted into chemical energy, carbohydrate. And that is exuded as liquid carbon exudates into the soil to feed the biology and then to drive soil aggregation and all that good stuff. So it basically starts with the sun. And the only way that we can grab that sunlight and do something useful with it is to have that green plant growing. When there's no green plant, there's no energy capture. When there's no energy capture, it's basically a dead system. And what's interesting about that is if you think about it, the only input the planet gets all day, every day when the sun's shining is sunlight. There's no incoming nitrogen or carbon or phosphorus, any of the minerals. We basically have no more nitrogen today as we did 1 million years ago. We simply cycle it and do clever things like the Haber-Bosch process to make fertilizer. But fundamentally, whether you grow grain or grass, your yield is a function of how much sunlight you can capture in a growing season. And we don't really talk about that a whole lot. And I think that's sort of an important principle. So the more we can keep that green plant growing in that living root pumping stuff into the soil, all these wonderful carbon products, because carbon is basically the energy that drives the system, the healthier our soil will be. And this is just a picture from a few years ago that I thought was a wonderful example. You'll see the green half section in the middle. That's winter wheat in the spring. And if you compare that to everything that's going on around it, it's basically the only piece of ground that's capturing sunlight. And you may think, well, okay, that's fine, Mike. So what? Well, in this case, winter wheat is grabbing sunlight earlier in the growing season, kind of that early spring, and again in the late fall before. So it kind of fills in those shoulder seasons whereas if we were growing simply wheat and canola, we're missing out on that opportunity to grab more sunlight. And then this is what you get as a result, is these wonderful roots exuding all these carbon products into the soil that attracts soil biology to create these dreadlocks where you see very little bare root, but you see all this wonderful, and this is sort of a sign that there's lots of life going on in these roots. What happens is the plant exudes these carbon products, attracts the soil biology, bacteria and fungi. They come and start feeding on that. And in exchange, they give the plant mineral, nitrogen, phosphorus, potassium, all the micronutrients as well. So that's actually the relationship that we have going on in the soil. And there's a communication where the plant is communicating with the biology, and they make these deals for nutrients. And that's basically how soil is made. Like this is when I say soil is a living system, this is exactly it. So these wonderful aggregates are starting to be formed, and that's the thing that gives soil structure. And where all the good stuff happens is in those soil aggregates. So fundamentally what we're talking about is that the plant and the soil are one. There is no plant without soil. There is no soil without a plant. And this is how it's evolved for 500 million years since plants started to colonize the land surface of the planet. Next principle is diversity. And again, this is just sort of looking in on nature and going, hey, how does nature function? Do we typically see just a monoculture of one plant or one animal out in nature? No, we typically see hundreds of species. So if we think about the prairies, whether you're in the Red River Valley where it was tall grass prairie, out my way where it was more kind of transitioning to the parkland, mixed grass prairie, or you're in Saskatchewan, short grass, dry prairie. There was a diversity of species of plants and animals and insects and soil bacteria and fungi and worms and on and on and on, all working together. And you may say, well, that's a nice thing to have, but so what? Well, the point is that when you only have one type of plant, and this is sort of an interesting example, you only have one job getting done. So in other words, you sort of just look at these plants and their different root structures. So if you only had one type of plant, and on the far left, you'll see in small letters is Kentucky bluegrass with this very, very, very short root system. Compare that to like an Indian grass that we have here in Manitoba in tall grass prairie. Look at the difference in root structure and the different jobs that are probably getting done because of that different plant. So the idea is that diversity, whether it's nature or use the example of an organization, if you only had clones of one particular type of person and they all had the same sort of skills and talents, only certain jobs would get done. You need a diversity of people, you need a diversity of plants, a diversity of animals so all the jobs get done in nature. And then finally, minimize disturbance. And this is an interesting one. And it's not that it's not that disturbance can't be beneficial, but it has to be sort of planned or managed. If you repeat something over and over and over again, it becomes chronic. And, these are the words that get used in medicine. Like a chronic disease would be something like an autoimmune disorder, where it just sort of chronically causes inflammation, like say something like colitis or Crohn's. And those are very difficult diseases to handle because it's just sort of repeat. And our bodies have a hard time dealing with that. Whereas an acute disturbance would be something like you break a leg, right? You have a bad accident, you break a leg. Well, that leg will heal if you do what you need to do. It's sort of like a one-time event. And that leg may even be stronger for it in the end, where that break happened, that may actually, and it's the same in nature. Whereas, so we need to be kind of careful on how we disturb the natural systems. And, sort of the classic one is tillage, and I'll talk a little more about that, but there's other forms of disturbance. High rates of fertilizer can be a disturbance. They can do things like blow up your carbon to nitrogen ratio. Pesticides, whether they're a herbicide, fungicide, insecticide, those can be kind of direct disturbances to things like insects or soil biology. And even monocultures, if we think what we've done, what used to be the prairies used to be basically like a big pasture, this diverse pasture of plants and animals. And, there used to be like 100 million bison roaming around the northern Great Plains, and they're gone. Those things have consequences over time. So nature typically doesn't like monoculture. It likes diversity. So if we look quickly at tillage as an example of a disturbance, what tends to happen when you drag a piece of steel through soil, whether it's a plow or a cultivator, deep tiller, disc, whatever it happens to be, these new vertical discs even, what you're doing is you're introducing oxygen into that system, air into the soil, and that tends to cause an explosion of bacterial activity. And that tends to burn off soil carbon and convert it to CO2, which then ends up in the atmosphere. Like a good chunk of the CO2 that's currently in our atmosphere is not necessarily because of burning oil and gas, though that's, of course, a contributor. There's a lot of CO2 that's in the atmosphere that's sort of legacy CO2 from loss of soil carbon out of our soils over the past few hundred years. It can also be destructive to soil biology. If you think especially fungi, which are kind of like the internet of the soil, you think they got these long hyphae, there's like thousands of kilometers of fungi that associate with the roots of plants in a healthy soil. And when you disturb the soil, you destroy that network of hyphae. And if you think about like the roots of a plant can typically explore maybe 1, 2, 3, 4, 5% of the area that the root of the plant occupies. If you think of like a wheat plant, when they are associated with fungi, it's probably more like 20 or 30%. So there's this huge increase in ability of that plant to uptake water and minerals when they're associated with the fungi. And of course, tillage can cause winter water erosion. We've done quite well with that, trying to minimize tillage. But driving around just recently, last few years, it seems like we've gone backwards a little bit with that. And we are seeing more, especially in the winter, more wind erosion and snert, black snow in the ditches. And that's, of course, just tragic. And it doesn't take much, like the thickness of a piece of paper times 1 acre is 1 ton of topsoil. And, the loss of that is just a tragedy. And tillage destroys the soil structure and the aggregation. The aggregates are kind of the good stuff. They're the tasty kind of candy, and that's what tends to get chewed up first when you introduce air into soil. And rebuilding those aggregates takes the soil biology to do that job, and that takes good management, a green plant, pumping carbon back into that system to feed the biology, to drive aggregation. And then finally, soil carbon, it's kind of like the fuel of the soil system. Carbon is basically energy for all living systems, whether it's us or a bacteria or a fungi or a plant. And when we lose that soil carbon, we're losing energy that could otherwise be used to grow grain or grass. So that's all I had. I'll just quickly go back here and we'll pause for a sec. I'll just pop up the principles. And let's check the questions and answers, see what we have. So there was a question about when Blaine was talking about livestock and the good things that livestock can do on the land. Is there other livestock that can work besides cows, such as horse, buffalo, goats, sheep? And it's like, yeah, of course, right? And there are progressive producers that are using multiple types of livestock together, like cattle and sheep, pigs, chickens, all that good stuff, goats. And there was a comment about dreadlocks, and yeah, they exactly look like dreadlocks. And when the root is, when the soil is sticking to the root. Question from Jamie. Hey, Jamie, good to hear from you. I think Jamie's in Regina. So welcome from Saskatchewan. Can you repeat how a plant isn't photosynthesizing when it's in reproductive state? Well, what happens is as the plant goes more reproductive, whether it's wheat or canola or a perennial grass, they've kind of gone through their growth phases. And as they go reproductive, and you can see this, right? The plant tends to turn brown, and it's putting all its energy from the root into producing seed, and there's simply less green leaf that is capturing sunlight. It's not like it's zero, but it's probably just reduced. So there are things you can do through good grazing to keep that plant in a state where it's kind of maximum photosynthetic capture is increased over the growing season. But that's not to say that allowing a plant to go reproductive isn't a good thing. There are good reasons to do that, to allow that plant to go through its full life cycle, and that probably maximizes the health of that plant and the depth and the resilience of that root system. That's probably the only way to kind of allow that plant to have a maximum root system, which will allow it to be more resilient when it's wet or dry or too cold, too hot. So yeah, these regenerative principles are simply, the past 500 years of science and biology, ecology, sort of just looking real deeply into nature and seeing that this is sort of how nature tends to work. There's always something green growing. You rarely see bare ground. You see lots of diversity of plants. You see a diversity of animals above and below ground, insects, and it has a nice soil armor. Anything you want to add, Blaine?
No, I think you got her covered, Michael. That's
okay.
Basically the principles covered. Get them in your head, guys.
Good. So I'm just going to stop sharing here, and we're going to move into our first speaker. So the plan for this this workshop today was that Blaine and I would sort of rip through the principles, and that's all fine and good. You need to have that as sort of the base of your understanding. Think of it like the base of the pyramid, right? You need that good, strong foundation, and that's what the principles allow you to have. But now, of course, it's like, how do we implement these principles into our practices, into our management? And our first speaker today is going to be Darren Maddess. He farms down at Deloraine, and Blaine and I have got to know Darren over the last few years. He's a producer in the General Mills project. It's a regenerative project where we're helping to helping farmers sort of implement these regenerative practices and figure out how best to do that. And I'll let maybe Darren say a few other introductory words and get into his presentation. Darren.
Yes, good morning, everyone. Good to see a bunch of people online here. I'll just get my screen up here and get going with this. Yeah, as said, I'm farming here at Deloraine family farm with my parents and my wife and kids here. We're covering about 3,300 acres. I think about 2016, we really started into the regenerative process. I'd been listening to some presentations, got curious, planned to start cover cropping a little bit then. And ultimately, the best experience I had of really seeing some of the benefits, which unfortunately I didn't take pictures of at the time, but it was turning a bad situation into a learning experience, was we had a field of oats that got hailed right before it was getting combined. So there was, my guess is about 60 bushels an acre worth of oats on the ground that year. And that grew. We were a wet fall that year, and I observed that field a lot and found it really interesting come late November, because we had such an open fall that year. I drove across that field, and I think there was one spot on that field I found some standing water, whereas other fields around, we had a field directly across the road that every field had water in it. So it's kind of that light bulb moment for me of something's going on here with these plants all growing out here. And the big lesson too I added to it was a lot of people would make the comment about, well, yeah, those plants used up the water. And I counter that with the fact that I could go to one slough in the field that had drowned out prior in the summer, so it didn't have any oats growing in it, that it was basically bare ground at the time, and there was no standing water in it. So it was, well, there's no plants using water up here, so if plants are using up the water, it should have water in it. So that kind of taught me that no, it's not the plants using the water, it's the plants are helping improve the soil, so the water actually infiltrated into the soil instead of running off. So I'll get into this a little more here with the why do I really want soil health on the farm. So like my story here just was that water right now, everyone I think on here likely experienced drought this past year. So getting water into the soil is a big reason, and keeping it there. So looking at these two pictures here of the conventional soil, you can tell that soil just looks really tight in that shovelful there, that you can see the cracking horizontally in it. That's that platy structure and that tillage layer showing the depth of the tillage in the past, versus the picture on the right. This is more of a regenerative field after a couple years of using soil health practices on it, and not even all the soil health practices have been applied to this field yet. But taking up that shovelful, now you can see that this is more of a crumbly soil structure here instead of being all tight together. And in a few spots there, it might be a little hard to see, but there are a few spots where you can see some holes, which would be earthworm channels. So by not going and disturbing that, those channels are remaining open, which is helping the water to infiltrate through those channels as well. Another reason why, and this is more I've learned since doing these practices, is weed pressure has changed on the farm. One of the things I've really observed is wild oat pressure has dropped. That I drive down the road and look at some of the neighbors' fields, and they're constantly spraying for wild oats. I won't say I'm not having to spray for wild oats. They are still present, but my wild oat pressure has definitely dropped off dramatically compared to what it has been before. Another example of a change in weed pressure is, I know I had one field that for years, it always seemed like stinkweed was a problem weed on that field. It would be there, it didn't matter how much I sprayed for it, what I did. And then that was one of my first fields I experimented with cover crops on, and it was fall cover, like fall seeded cover crops. And it was a couple years later, all of a sudden, it came one time I'm driving around looking at that field, and it all of a sudden was, wait a minute, there's no stinkweed out here anymore. The only thing I've changed is these cover crops. So it's got to be the covers that, and a little bit of research led me to understand that with the life cycle of that stinkweed, by seeding a fall cover crop, it basically took the place of that weed that weed was trying to cover bare ground in the fall. So by me covering it with other plants, it decided it didn't need to grow anymore. Other benefits or reasons why I'm going down the soil health road is I don't like paying for fertilizer, especially at these prices. So anything I can do to help out on that fertilizer bill while maintaining yields, or more importantly, maintaining profitability, is great. That it's not something you can cut out immediately. You're still going to be using fertilizer, but anything I can do with this to help reduce that need is great. So as Blaine and Michael,
sorry, Darren,
yes.
can I just get you to turn your video off? Your bandwidth is low, and maybe if you just turn off your video, that'll help out, and then we can maximize your audio.
Okay.
Thanks. There you go. Thank you.
Yep, hopefully that helps.
Yep, sounds good.
So as Blaine and Michael covered the soil health principles fairly well here, I won't go too in depth on them, other than just adding some slight interpretation I have on them. That in my mind, I've kind of grouped the keeping the soil covered and the reducing or eliminating disturbance as those practices. They more so accomplish the maintaining where you're at. You will go forwards with those processes or practices, but the big part I see with those is just that they prevent you from taking that step backwards. Meanwhile, the living root, diversity, and livestock, those are the ones that are moving forward more. That, I guess, in my mind, if I am gonna rank any of these as more important than another, the living root is probably the one that now, after a few years, I have decided in my mind is the highest priority to me, or gonna be my highest priority. That I still want to do as many of these principles as often as possible, but from now on, my number one priority is the living root. So how am I implementing some of these principles? So first off, reduce tillage and soil cover. I'm using a disc drill now to seed, and put the picture of the disc drill and the stripper header together here because those two just complement each other so well. That the disc drill, now I'm not disturbing the soil or barely disturbing it when seeding the field. That I can go out and seed a field, and you can't, basically the only way you tell it's seeded is you see the wheel tracks of the trampled stubble out there. As you can tell on the right, to the left is seeded, straight ahead is unseeded, and there's just a little bit of the headland showing on the right side that was seeded. That very little disturbance there, and that is into the stripper stubble. With the stripper header, the big benefit of it working with the disc drill where they become complementary is the fact that one of the primary concerns people have looking at a disc drill is hairpinning. That the hairpinning is the pushing of the straw down into your seed trench and not getting cut, so your seed doesn't get the good seed to soil contact. By using the stripper header, and the other thing I've done as well is going to RTK guidance. Now I am always aiming to seed between the rows of the previous year. So that tall standing stubble now is not on the ground to get in the way of the disc. So if it isn't in the way of the disc, it doesn't get or doesn't need to get cut by the disc and doesn't cause a hairpinning problem. And at the same time, if it does lay down on the ground and get in the way of the disc, it's more likely to get cut. That I was explained or had explained to me one time about, think about breaking a stick with your hands. What one's easier to break, a long stick or a short stick? Well, the long one is, so it's sort of the same thing here where it's easier to slice through that long straw than it is short straw. That it's better supported by the ground, so the disc will slice through it better. Other benefits here is with that stripper header, now that long straw, it takes longer to get fully down on the ground and making complete contact with the soil, so it doesn't decompose. So that leads to my cover lasting longer compared to chopped straw that instantly, as soon as it's out of the combine, pretty much hits the ground and is in contact with the surface and can start decomposing right away. As far as buildup of residue over time, not really going to be an issue, because or if it does become an issue, that's just something to observe and realize that you likely need to make a change to what your practices are of you're likely lacking in biology, or are you too high in carbon in your residue that you might actually need to change a crop rotation to have a crop with lower carbon in the straw, like a lower carbon to nitrogen ratio. Other benefits that I've seen using this system here is my fuel consumption has gone down. The stripper header, running it, I'm probably around, well, from what I've seen, I'm about 40% reduction in my fuel consumption on the combine. That I was running right around the 1 gallon per acre mark when running a straight header, and the stripper header is consistently about the 0.6 gallons per acre. Another thing that this year I have noticed is with all the snow we have and the winds we have is I am holding much more snow compared to either the short cut stubble or especially the soybean or pea fields that have basically no stubble. That I know my most fun observation was early January, driving down the road and going past one field of soybean stubble and having to drive through drifts constantly going past that field. The next mile was strip stubble and the road was perfectly clear. So that was my quick and easy way to measure whether or not I was catching snow without going into the field then. And interestingly enough, in the afternoon driving down the road, I noticed the snowplow had the same observation as I had, because he came down the road and only got halfway down the stretch with the stripper stubble and turned around and went back. We'll see here whether this plays very well for you or not. Just to show if anyone has anxiety about going through the strips double seeding, I've included this video here, just quick clip of my seeding. All right, hopefully that played, you guys.
Yep.
All right. So here's some more pictures of the soil now after a few years of these principles being applied. And this just shows, I put these in because of a lot of this is the benefit of the lack of disturbance and keeping the soil covered. That picture on the left there, that shovel full of soil, Intel, the structure there isn't as great as the picture I had earlier, that we don't have as good of aggregation yet. This field hasn't seen a lot of soil health principles yet. But the big thing, this picture, you can really see a lot of the earthworms still open in this plot of soil here. So that's the big benefit there we're seeing early on after having the soil, or the lack of soil disturbance, is keeping those channels open. Then on the right, this is just the example here of, with the soil cover, I just brushed some of the residue away, and it's really nice feeling when brushing that residue away and right to the surface in the spot. I was able to see the aggregation, or a bit of that cottage cheese like structure of the soil showing up right at the surface. That's keeping the soil covered. Another thing it's accomplishing, beyond just keeping that temperature cool and protecting the raindrops, or a lot of that protection now is maintaining the structure here to the surface. That structure at the surface now helps to allow the water to soak in, because you can have fantastic structure underneath the surface, but if you're a powdered, compacted, tight soil at the surface, if the water can't soak through that first quarter inch of soil, doesn't matter how good it is underneath, it's got to get in before it can soak in further and fill up the profile. So I'm now happy to see that this structure is forming right at the surface, and we're able to maintain it now. So the cover crops now that I've been incorporating into the operation, big reasons why I'm using cover crops is they're the opportunity to have that living root in those shoulder seasons when the crop isn't growing. Another thing is they're the opportunity to bring in diversity of living plants that were often growing a monocrop, wheat, oats, canola, whatever. Many of us only growing one of them at a time. So if we have a cover crop, that's that great opportunity to have something else that we don't normally grow here. And by having that cover crop growing in those shoulder seasons, now we're feeding that soil biology the rest of the year, not just our growing crop. That our growing crop is feeding the biology up until it goes reproductive. From then on, it's pulling carbon back out of the soil to make its seed. So it's important to have that crop the rest of the year. And again, I think I on this one all throughout this presentation, that especially after these dry years we've had, that infiltration is one of the #1 priorities I have. So when am I seeding the cover crops? There's basically, in my mind, sort of your 3 different main windows for seeding them. I'm looking at either the fall seeded after harvest, interseeding it into an existing crop, or companion seeding it at seeding time. So for the fall season, ideal is I try and get out there as soon as possible. If I can have the drill in the field at the same time as the combine, I will. That is definitely a challenge, but I keep trying to achieve what I can. This field here is an example of you don't need fantastic growth for it to be effective. That I think a lot of people look at this and kind of go, well, that's pretty small. Like, is that doing much? No, this is doing lots. This is like, would I like to see it better or bigger? I mean, absolutely. But this still is fantastic. You go and dig into the soil, look at the roots on the plants, and that is doing a lot of good for the soil. So saying we don't have time in the fall or we don't have enough growing season, yes, we do. We have it here. Interseeding cover. Now this one is a bit more of a challenge to accomplish in my mind. I've been trying it a bit. I've done a little bit of interseeding into wheat, and the other one that I've really been experimenting is interseeding into canola. Big reason why I've really focused on the canola is because of the canola not supporting mycorrhizal fungi, and in the system, supporting fungi is really important with how bacterial cells are. So if I can get plants into the canola crop that support fungi, that's going to help out a lot. So my method of interseeding has been to come in right around herbicide timing so that I still have weed control options in crop that aren't, or so I can control the weeds, and I can also put in species that herbicide would have killed, because now I'm seeding them at a point when they're not gonna be sprayed. So this field here is actually canola. That what I did is my drill is set up on 10-inch spacing. And when I seeded it, I locked out every other opener and seeded the canola on a 20-inch spacing. And then herbicide timing, came back in and seeded in between those rows with cover blend. This one was mostly some clovers, and what you can see in the potted canola there, the purple flowers, that's Phacelia. This was an early experiment of me trying to find out what species I can use in here, because one of the concerns is I also don't want it to be a problem with the crop, either a competition, or big concern really is the problem of harvest. I don't want it to interfere with my harvest. So this here with the Phacelia at this rate, it might cause some interference. If you're swathing, not a concern. Now as more of us head towards straight cut, yes, this is more of a concern, especially if you are trying to avoid spraying it. If you're seeding cover in, I expect you hope to avoid spraying. So there are management concerns here, trial and error, that we learn what we need to use. So is intercropping. Big reasons I've tried intercropping is, again, it's another opportunity to increase my diversity. Now I'm growing 2 crops at the same time on the same field. So right there, I just doubled the number of species on that field. Reducing my fertilizer. I have been determined when I intercrop with a legume species to do it without additional nitrogen. There's a lot of trials out there trying to find if there is an optimum nitrogen rate. There are at times likely benefits to still applying nitrogen. I am just very determined that I also want to use this as the opportunity to have that year where I can go without fertilizer to help out the soil as much as I can that way and apply that principle. Another opportunity here is that this is allowing me to increase my residue that's on the soil when I'm growing something of a low residue crop. So in this case here, this picture of peas and oats together, now I have those oats in there that are going to help to provide some ground cover after harvest and a higher carbon to nitrogen ratio in that oat straw to not break down or decompose as fast as the pea residue does. And another example here where this picture fits in good is the risk management, that this is right where water ran in the summer when we had a big rain event and the peas drowned out, but the oats were able to survive it. So that, in my mind, was risk management right there of at least I didn't lose my entire crop on those acres. So some of the intercrops I have tried is this oat pea, pea canola, wheat and flax, soybean canola, and fall rye and hairy vetch. For the most part, those ones, growing them can be reasonably easy. Many of them are fairly simple to start with, but a person has to always consider the separation, how easy they are to separate, and another major consideration before planting a intercrop is the marketing, because you might not be able to get a 100% separation, and some markets might not accept that. Some may want complete purity, whereas other buyers might be okay with some contamination. So a quick example here of how I've been separating them is this on the left here. We have the oats and peas going across a vibratory screen. This is just a Garrett vibratory. I started out with what's in the background there is a navigator, and I was not satisfied with the job it did for separating. So I added in this vibratory screen, and it is my number one recommendation to anyone who asks about separating intercrops. Is it's reasonably economical to buy, and you can change screens in it pretty quickly, and it's just simple and works. But if you get into something that doesn't separate by size through the screens, then like on the right here, I am running the fall rye and hairy vetch through spirals to separate them, because the round seed will spin out faster and fly off the inner spiral and separate from the rye, which stays on the inside. So this worked well for it, just extremely slow. So it's one of those things to take into consideration if looking at some of these harder to separate intercrops is how long is it going to take? How much time do you have? How patient are you? Moving on here to what I've been doing to reduce my fertilizer. I have started working with humic acid. I've been placing it with my fertilizer band. I've done about 2 years worth of trials now on one field. I've set up trial strips comparing different rates of nitrogen with the humic acid. And so far, I've observed on my 30% nitrogen reduction, I've had either very little yield loss or no yield reduction. And I think when I've seen a slight drop in yield, then the really important thing to do is go look at profitability. Did my yield loss, was my lost income of yield greater than or less than my savings? And in that scenario, my profitability was still higher with less yield. That's one big thing. I know Chris Nichols especially is one who pushes. She hates to hear the word yield, that let's look at profitability. That is the important part for keeping the farm going, is being profitable, not necessarily growing the biggest yield. Another thing I have tried is using foliar applied melted urea, and when I'm doing that, I am also adding humic acid with it. This is something I just tried this past year, so not a lot of experience with it yet. I think Alex might get into this more in his presentation. I know he has done this more than I have, so if there's questions, I might also defer them to him later on here. But just to quickly summarize my experience with it is, it's supposed to be a higher efficiency of nitrogen use compared to soil applied. And the other big thing I noticed was I monitored the Brix level in the plants when I applied this, and it increased my Brix from 9 to 14, which, to explain what Brix is it's the amount of plant or amount of sugars within the plant, and our goal is to have more sugar in the plant. That the more sugar, the healthier the plant, the easier it fights off disease or insects. So that was one of my goals with this, and also the humic acid with the urea also acts as a bit of a stabilizer for the nitrogen. Into this, I have attempted, only succeeded at completely once. It is definitely a challenge for a grain farmer getting animals on the land. I did in 2019 a field, I seeded a full season cover crop, took the opportunity with this full season then to put in a lot of diversity. I think I was about 8 or 10 species in the blend I had out there. Worked with a neighbor then who had cattle nearby, put up the fence, and we put the cattle out there. I had, it was a field of about 90 acres, and he brought in 60 cow-calf pairs, and we got about 6 weeks worth of grazing off of this in the end. So I will admit, I know next to nothing about cattle. So for me, from my perspective, I thought it worked out fairly well in the end there. Cattle farmer was pretty happy in the end too, as I understood. He didn't complain. So it was good. It was nice to see the cattle out there. We got manure now on the field from them, added the microbials that way, the biology. But yes, I will admit, it has been a challenge getting them on another field. It takes planning. That the big challenge as a grain farmer is I'm not accustomed to thinking of how to have water available out there. I'm used to the thought of if there's standing water on the field, that's a problem. Whereas now I need to figure out how to get water available on the fields where I want the animals in is my biggest challenge. So moving forward, my goals, this is just a quick list of what I have in my mind as my goals going forward, is especially focus on more plants more often, get those cover crops out there. When I look at my overall yields on some of my fields this past year, in 2020, with the dry fall we had in 2020, I did not put a big focus on seeding cover crops in 2020. I did have one field that I did get some on, and then it went into canola in 21. And when I look at my canola yields from 21, that field is actually the field that had the highest canola yield on it. So the concern about cover crops using up water for the following crop, I am no longer concerned about that with fall growth. I'll put in the caveat here. I am always concerned about spring growth. That is something I managed, that in this year, I had fall rye was one of the components in my cover crop blend. So in the spring of 21, when it was dry, I made the decision to go out there and spray that field first thing in the spring, because come springtime, I did not want that rye using up water. I knew come springtime, I need to conserve water. In the fall, I was more concerned in the fall, let that plant grow and it'll help improve the soil structure to improve the infiltration so that the snow actually, or the water from the snow actually soaks in instead of running off come spring. Compost is something I know I've been looking at considering doing. It's anyone who's really involved heavily in the soil health seems to be always talking about compost or doing it. And I'd like to. It's probably been labor is one of my biggest things preventing me from doing the compost, and just a little bit of learning how to prepare a proper compost. And from that, then I'd like to really focus on the extracts in order to put that compost into my furrow at seeding time to get the biology out of it and into the soil. Another thing that has been on my mind for a number of years is controlled traffic farming. That it just has intrigued me for a while, for helping with the soil, just to prevent compaction. That when I'm out in my fields, compaction is, again, one of my huge concerns. It's preventing that water from getting into the soil. It's preventing those roots from really exploring the soil as well as they can. So if I can prevent compaction, that just goes to help everything out down the road here. And it comes in really handy with controlled traffic just for when I want to do trials, just to have everything matched up. So it gets simple that way. And with trying interseeding, the thought of controlled traffic solves a lot of problems there too, of wheel tracks. So that concludes what I really have. If there's any questions,
Darren, yeah, there is some good questions here. I'll just answer a few or ask a few of these questions. Then Blaine will take on the that first question about water. So more to the farming details. Question about stripper headers. Are you able to harvest earlier with the stripper header?
I won't necessarily say we can harvest much earlier with the stripper header. Your grain still has to be mature to harvest. Right. The big thing, I guess, is looking at something like with oats, where your straw might be green while your seed is actually ready. In that case, yes, I can go earlier. I don't have to wait on that straw to dry down the same way, because it's not going through the combine, so it doesn't matter. Green leaves, now on the cereal crops, if there's a bit of a green leaf, it's not too bad at coming off. But if you have broadleaves out there, yes, the leaves on broadleaf plants will strip off and go through the combine and probably get chewed up a little bit, and that's when they can become an issue in your sample.
Right, that's a good segue. Question about stripper header on canola or other crops besides cereals.
Yeah, as far as the stripper header crops I'm using it on, cereals, all of my cereals go through the stripper header. Canola, as long as it's a good pod shatter variety, it's going through the stripper header. I personally haven't done a lot of the drop pans under the header to check losses. I trusted people I talked to who said that the losses were low. The way I've really confirmed that my losses were low is this fall after harvest, after we had some rain, a couple weeks later, driving around, walking around in the field, there wasn't a lot of canola growing. Of course, there were some canola plants, seedlings there growing that I won't say losses are zero. Every method you have of combining, you have losses, but with the stripper header, I'd say my losses were no higher than any other method.
Okay, good, thanks.
I guess, yeah. Soybeans, of course, are a no-go for the stripper header. You can't get down low enough. Peas are possible, but not recommended. That if I'm combining peas, my first choice is still to go to the flex header.
Question about livestock. What kind of agreement did you have with the livestock owner? Did you charge him for grazing? Did you pay him to come in and graze your cover crop?
The arrangement we had on the grazing was I covered the cost of putting up the fence. It was a field that I figured we'd be aiming to do this off and on. So in that scenario, I decided let's put up the permanent fence here. Helps to keep me on track of trying to do this more often if I already have the fence there. And then at that, I got paid for the grazing. Off the top of my head, I can't remember exactly. I think it worked out to about 50 cents an animal unit per day. Essentially, the big thing in the end was what it cost to put up that fence. I got half that cost recovered that year.
So that's an investment over time.
Yeah.
Yeah. Okay, and then we have a question about water. Was curious if you had discussed the benefits of regenerative agriculture practices to surface water quality and quantity resulting from their adoption, and if not, elaborate on some of those benefits. Blaine?
Yeah, thank you, Michael. That is a great question. We either curse it or love it, one or the other. It's either too much or too little in agriculture, it seems. But here's an interesting stat for you all to kind of contemplate, that Manitoba agriculture says that the average acre of farmland in Manitoba will infiltrate less than 1 inch per hour. 1 inch per hour. So that means if you have a 1 inch rain in half an hour, half the rain runs off. And we saw evidences of that this year in a severe drought. We still, after a hard little rain, we saw water ponding. So that means the rainfall is not very effective. On some of our regenerative farms, like Darren's, that we've been doing this for a few years, we can actually put in 4 inches in 10 minutes. So that makes a huge, huge difference. I'll just share one more example from my own farm. In 2014, we had a major rain event, as a lot of people did in Manitoba and Saskatchewan. And on my operation, to my knowledge, I never lost 1 ounce of rain off that farm. It all infiltrated. And I could not believe it when I walked around. And what was happening is the water all went in, and then very, very slowly it started to move across the landscape. About 3 or 4 or 5 days after the rain event, I couldn't figure out why I was walking in water with my rubber boots. And it was incredible to see, as that land got healthy, how the water cycle worked different from what we're used to. So we can make huge differences in how, just by the way we farm, and what happens to that water. You know, there's places in the world in 40, 50 inch rainfall that are basically a desert because the water all runs off. It's totally ineffective rainfall. And so the way we farm makes a huge difference. If we practice those soil health principles that Michael and I talked about at the beginning, makes a huge difference on how rain enters that soil.
Yeah, if you think about it as the root cause of what's going on with water, many of our problems are because of degraded soil, and that needs to be the thing we address. Building infrastructure, small dams, all of that is useful, but doesn't necessarily address the root cause. And if we can get that water, whether it comes as rain or snow, to infiltrate where it falls, we can solve many of those problems. If you look historically at what infiltration rates were on native prairie, they were probably between 10 and 20 inches of rain per hour was the infiltration rate. So we've taken that from 10 to 20 to less than 1 in 100 or so years of prairie agriculture. The hopeful part is that just with a change in how we do some of our practices, we can regenerate the soil structure, the aggregation, and therefore the infiltration. Okay, I think we're going to move on. I'm going to save a question from Douglas here. We'll maybe answer it. But thank you, Darren. That was excellent. Really appreciate it. We're going to move on to Alex Boersch. Alex, are you there?
Yeah, I'll just unmute myself here and throw on the screen share. All right, can you guys see that?
Yep.
Perfect. All right, I'll try and make it quick.
Yeah.
So my name is Alex Boersch. I farm in the Red River Valley, just west of Winnipeg in Elie. We farm about 5,000 acres, 1,500 of which is actually an organic. And we've kind of gotten into this regenerative route in 2017, 18 is kind of when we started. And there's been a lot of different things that have changed quite drastically on the farm, but I'll get into our goals as to why. Why is it not switching? There we go. So basically our long-term goals are to increase stable and active soil organic matter. And I think the key is active. We've built up organic matter on our soil in our farm, probably from when my dad took over here in the late 80s until now by about 2%. But our water infiltration hasn't changed. It might be has even gotten worse, who knows? And we've seen it through some of our Haney tests that our soil activity and our bacterial to fungal ratios have been way off. And with cover crops and zero-till, we've been slowly actually seeing some changes in that. But I think that's the most important part, is not just basically raising our organic matter levels, but also keeping active by feeding those microbes a diverse diet. Water infiltration is huge for us with our heavy clay gumbo soils. It has been the single biggest thing that's kept us from going into zero-till, because our soils will get so sticky, and in that soil runoff, when we get a bit of flooding or anything, it doesn't warm up. And I think that just has to do with the fact that we don't have a super active soil, and the soil texture to begin with is tough, but I think there's a way we could improve it and make that part of the, I guess, the regenerative principles possible. We want to reduce our dependence on chemicals, whether that be herbicides or fungicides, with balanced nutrition and soil health and increased bricks. We want to reduce our commercial fertilizer use, spoon feed our crops more nutrients through biological cycling instead of just synthetic fertilizers. Basically, we just want a healthy soil. So overall, I guess there's two ways of approaching regenerating our soils. One of it is through diversity of plants, and the other is how can we reduce the harm that we do and increase our fertilizer efficiency from our fertilizers, from our synthetic herbicides, etc. We've been adding a lot of carbon products into our rotation. So we add fulvic acid to our herbicides, which is, we've been able to reduce our herbicides by at least 25%. We've cut, well, it's been easier to do now in these dry years, but we've pretty much cut back to zero fungicides, whether it be on the seed or like on the leaf. So we've kind of replaced it a little bit with biologicals as well. especially on the seed, but and seed primers. We also buffer all of our high salt fertilizers with carbon, trying to keep that carbon and nitrogen ratio tighter, and also complex the salts. So we know that it's a huge shock on our soil microbes and anything that's living in the soil when we put 100 pounds of nitrogen or 150, whatever people are putting, and 40 pounds of phosphate. We know we're burning all of our mycorrhizal doing that. So we're basically blending in humic acid with our liquid 28 and granular humic acid with our phosphate. And we've reduced our fertilizer overall on our farm by about 30% in the last 5 years. And then that's not including, I'd say overall on our farm with intercrops, we've probably reduced our fertilizer use by 50%. we want to increase our bricks, so lower nitrates. Carbon to nitrogen ratio is super important there, nitrogen to sulfur, etc. And then we use liquefied urea with humic acid for top dressing, so to give our plants a little bit of a boost, because we're cutting back our nitrogen so much up front. We're going over it with a flat fan, and we're spraying on liquefied urea, and I'll explain a little bit more why later. And we've started applying 2 to 3 metric tons an acre of compost biannually. That's just a picture of us applying that in our fields. So then from a diversity perspective, we're going to continue to do more intercrops and relay crops because they give us easy diversity, fall cover in the case of relay crops without having to seed another cover crop. And they're giving us the opportunity to reduce our fertilizer needs. And then cover crops, the goal is to get them on every acre. We had the same observation as Darren, that we were scared of losing moisture, but wherever we had cover crops last year were our best crops this year, despite the severe drought and only having 3 inches of rain during the growing season this year. So that's no longer a concern to us. And going forward, our goal is every single acre is going to get it. And I think one other way that's going to help us to also achieve going almost all zero till is going to be seeding into green cover in the spring. So having overwinter cover crops. Yeah. So the first thing I'm going to talk about quickly is just why do we use melted urea? So when you're melting urea, so 2800, a lot of guys top dress with 2800, but then you can't go over the leaf because you burn the plant, because half of the 2800 is a nitrate form. And so when we're melting urea, then it's basically 100% the ammonium or urea will form. And then when you're spraying that on the leaf with the humic acid, you basically have no leaf burn. You don't need a rain for uptake, and we're increasing our bricks. And when a plant is converting nitrogen, it basically, when it's taking it over the soil as a nitrate, it needs to go through the nitrate reductase and get converted back to ammonium. So basically to the amine form, which is what the melted urea already is. So you're skipping that. That takes about 30% of the plant's energy to basically reduce that nitrate. And it's also reducing the bricks levels in the plant. So by doing this, we're skipping all of that. And I think with about 10 pounds of melted urea, we get the equivalent of when people are top dressing with 30 pounds of N with melted, so 10 gallons of UAN. And we're not having any crop burn, no worries about rain, nothing. It's worked really well, especially in crops like canola, corn, and wheat. This is just an example. Like, we have lots of Hutterite neighbors, and they have a lot of hog manure. And when they put hog manure before corn, they usually add another 60 to 80 pounds of N with anhydrous because they think that's not even enough. And there's not enough nitrogen release in the first year. So this was 2 years ago, and this corn is non-GMO corn that had bad hail damage. and in August, and like basically stripped almost, and then had a killing frost at quarter milk stage, still did 140 bushels, and all we did was put 2 times 10 gallons melted urea at V4 and at V10, and we added a little bit of micros and kelp as well, humic acid. But yeah, it was incredible. It would have been an unbelievable crop had it not been for that frost. So, and then I guess getting more to the plant diversity part, why do we intercrop? I think it's the liquid carbon pathway is the key to improving our soils. Like, plant root inputs build soil carbon 5 to 30 times faster than carbon derived from above ground biomass. So when Darren was talking about how he wasn't worried about his cover crop being so small, this is why, because you're going to build more stable organic matter through your root exudates than you will with basically your top vegetative growth. And then there's so many synergies from harvest standability. So like if you have flax with lentils or canola with peas holding that crop up, you have N fixation, higher P solubilization by, for example, flax or by peas, and then less disease. And then the weather risk, like Darren talked about before as well, where we've seen it, for example, this year with our pea barley. The dry areas were mostly barley, and then the lower areas where there was more moisture, the peas were dominant. So you just get, the crop can adapt more to its situations. I'll just show you some of our cover crops. So our intercrops, Piola, this was a couple years ago. And it was kind of funny because it was the only field that we didn't have to spray for flea beetles. And this hasn't always been the case when we've intercropped. Like some years it seems to help and some years not. But I think the peas germinated first and maybe confused the flea beetles. So the flea beetles never came into this field. And it's extremely healthy. And that's what we see in most of the intercrops, is that you just see an increase in plant health. You'll see better nodulation, root growth, as well as they're competing with each other. This is just an example of how, like, these were maple peas that have they lodge really easily on their own. You just see the peas holding that up and making that harvestability pretty easy. And for some of the intercrops, if you start simple, you don't need anything fancy to separate them either. Like a simple screener can get you a long way, and it's actually fairly quick. It is more work, but it's not too bad. And this was different last year. Like the ROI was not as high on intercrops to a certain extent last year because fertilizer prices were low, but commodity prices were high. But when commodity prices are low or when fertilizer prices are high, I think it really changes, because you really have these huge cost savings with the intercrops and the diversity. And so, for example, fairly typically we could get probably about 40 bushels of peas and 10 bushels of canola with no nitrogen. And we found that we did some trials with adding nitrogen. All we did was delay the maturity by 2 weeks. We increased the canola yield a little bit, but we decreased the pea yield, and the profitability was worse. So we've gone away completely from adding any nitrogen into our intercrops in those scenarios. So it's just a nice way to look at, visualize the potential. Obviously, some of these numbers can change, but overall for risk mitigation, I think it's a good tactic. And it allows us to grow things that we maybe won't typically grow in our areas. Like lentils haven't been grown in the Red River Valley for a long time because of disease issues. And I read a lot about flax intercropped with chickpeas reducing disease pressure. So we decided, why not try it on our farm? This was in 2019. We did black lentils with flax, and we put only 3 pounds of flax. And the crop was incredibly healthy. And wherever there was no flax, it was horrible to harvest because the lentils were flat on the ground. And actually, with only 3 pounds flax, we ended up with 20% flax in the sample. and it was one of our more profitable crops. It was unfortunately only on 80 acres, but yeah. This is pea oats. We've noticed that oats really benefits from the peas. The flag leaves are huge, and the test weight is usually higher as well, but it is a more difficult crop to separate, and you have to be really careful marketing it because there's pea chips can be a real issue. Peas and barley has been a little bit more hit and miss, but this year, in a drier year where we had to reseed some peas, pea barley was way better than our pure barley or pure peas on our farm. Out yielded both by probably about 30% despite being seeded in June. So it was a very positive note there. Soyola is one that we really have to work on. We don't want to grow any Roundup ready canola, so we really should be finding a Liberty Links soybean variety so that we could match up herbicides, because we could only spray for grasses otherwise. But yeah, we definitely have to work on that one. That one I'm not 100% sold on yet, although it is a nice mycorrhizal bridge in this scenario. So this is something that we're getting more and more interested in, is underseeding crops, because then you don't have the issues of separation, which take a lot of time and work in the fall/winter. And you still have that green bridge, and it actually grows into the fall, whereas some of the intercrops, they mature at the same time, you combine at the same time, and you still have that issue. You have to seed a cover crop afterwards. And so this is, for example, canola underseeded with some alfalfa and clover. And that worked out extremely well. We just matched pound for pound what the seeding rate of canola, and so we just poured in a bag of canola, a bag of alfalfa clover blend, and into the seeder, and it blended really well, and that worked out really well. So that was in 2020 when we had an extremely dry fall. And after we had combined, about a month later, we went and dug up some of the roots, and we couldn't dig to the bottom. We got to about 16 inches, but the ground was so dry and hard that you couldn't go any further, but the roots were still going down way into the bee horizon. And we were worried, like, is this going to be an issue in the spring? And we were also worried in the spring because it was still growing in the spring. So we tried killing it with Roundup, which we try to avoid using, but we couldn't, it just didn't die. So we just killed it with Curtail M in the oat crop that we seeded into it this year. But we were worried that we lost way too much moisture, but it ended up being our best oat yield by 10 bushels. So I'm not too worried about it going forward. I think just having diversity there and something growing in the fall just helps either way. And having that green bridge into the spring is a great thing to have. This is just red clover underseeded into fall rye. And then we seeded oats into it the next year. And it got a little too strong. So I think our seeding rate was a little high, but there's a lot of potential there. And this is, I think, my favorite one for extending our growing season in Manitoba, and also potentially for grain farmers creating a partnership with livestock producers, if you can find them, without actually having to lose an entire field for a year for grain production. And that's hairy vetch and corn. Both of these the vetch is a biennial, so it'll grow right until freeze up. And the corn has a really long photosynthetic window. So I think this is probably one of the ways we can maximize our photosynthesis in our climate the most, because you'll have that vetch in between the rows. Also helping with weed control. The vetch is partially resistant to Roundup, so you can still spray it with Roundup and you won't kill the vetch. You just have to use a little bit lower rates. And no, I think there's a lot of opportunity here for fall grazing as well. I've had a lot of friends that love using this mix after combining, sending the cows on here and grazing, because the vetch is a great protein source and they can balance it off with the corn stover. I think it's an amazing mix. And we've also done it with underseeding alfalfa into non-GMO corn. So that's compared to, then we have our fall seeded cover crops, which I think have a lot of potential as well. And this is one fall seeded cover crop where we just basically took all of the leftover seed that we had from the spring, which is like wheat, oats, flax, lentils, peas, soybeans, and then we added some sorghum Sudan grass and just seeded it all together. And it went through 3 pretty hard frosts and grew pretty much right up to the last killing frost. And then we did Austrian winter peas, which we've grown a bit in cover crops because it can survive down to a -12 frost and still grow. And we did that into a fall rye stubble. And we also had a lot of volunteer fall rye. And there you see the nodulation there. And that was only after about 3 or 4 weeks of growth. There's a close-up of that multi-species that we did just from whatever we had left in the bin. And this is a picture of Austrian winter peas still growing after the first snowfall. So I think we have a lot of potential, like Darren said, in our growing season. It's maybe not as ideal as we go further south, but we can still do a lot with cover crops. And this is just an example of that year we didn't have the best catch of sweet clover in our fall rye, but then we went and seeded another cover crop into it. And seeding into a taller crop like that is no problem. It's just nice to see. And then this is a multi-species cover crop that we seeded with buckwheat flowering, and it was just incredible, the insect, the buzzing in that field when you would walk or sit in it that fall, and the amount of animal and wildlife you would see in there. And that was seeded August 20th. So there's lots of potential in our growing season. And what's kind of funny though, these 2 fields are side by side, and this multi-species cover crop was seeded after tillage, and the sweet clover into fall rye, I seeded another cover crop into the fall rye, and there was a bit of sweet clover everywhere. In some patches there was a lot. So we got 6 inches of rain that fall in 3 days, and that was 2019. And the field on the left where we did zero till, and there was some plant diversity there, I could walk in that field no problem. There wasn't a puddle in that field. The field beside it that got 1 pass of tillage but had a really diverse, there was about 8 different species growing in that cover crop. But despite the cover crop, it was just a puddle of water. I couldn't walk through it or anything without having about 2 feet of mud on my boots. So getting to zero till is going to be a huge goal going forward. And I think seed to N ratio, having those green covers going into the spring, like that alfalfa coming up in the corn that was underseeded in the corn, are going to be key. And then the cover crops too, like for zero till, this was the Austrian winter peas into the fall rye. And you can see how that straw, because you changed the C to N ratio by adding those peas, it was so brittle, it was like dust. It would just break apart completely. And so seeding into that in our heavy clay soils then wasn't a problem at all. So what's next for us? Our goal is definitely, after what we've seen from like Darren and other farmers, stripper header, I think, so we don't seal off our soil with the chaff, and then we can grow a cover crop in there. And I think that will be what will enable us to potentially go into all zero till. Controlled traffic for compaction, I think this is something we should build towards. I think we can achieve a 50% reduction in synthetic inputs between the compost and cover crops. And how can we incorporate more diversity into our cover crops and still keep our costs half decent? And maybe a way to use the cover crops better is if we can integrate animals on our own farm, and we're potentially thinking about integrating sheep ourselves, because it's been so hard to find other livestock producers in our area to work with, because there basically are none. Yeah, that's it.
Thanks, Alex. Thanks, Alex. That was excellent. question here, maybe for both you and Darren. Start with you, Alex. There's a question from Douglas. He's just with your reduction in fertilizer, whether it's 50% or 30%, what does that mean in actual? What are you currently now going to be using for fertility in pounds per acre of actual NP? Let's start with that.
So this year is a little bit different than a normal year because we had such a bad drought that there's higher residual in. So we're taking that into account. But without taking that into account, like let's say on a normal year, my neighbors here in wheat would be at like 130, 140 pounds N up front, or on canola up to 150 or on corn. And we're probably putting on something like 80 pounds up front on those crops and then less on stuff like oats. But yeah, that's where we'll start off with.
Good. Darren, you want to?
I can,
Yep.
yeah, I'll
Go ahead.
comment on, I'm basically soil testing every year. So I've been doing variable rate fertility for a number of years. So my 30, if I'm working on a 30% reduction, it's always based off of soil tests. I guess the advice a little bit I'll give, or I've been given even starting down the road of reducing fertilizer when adding humics, is don't jump to huge reductions off the bat. That it's a process. That kind of maybe the first year, look at your replacing fertilizer dollars with humic dollars, that spend maybe the same amount of money and just change them from one to the other to help prime the system.
For sure. Like it took us probably 3 years. Like we did about 10% reduction per year of what we were previously doing. Roughly speaking, like obviously, like Darren said, it's a little bit based off of soil tests, and your field a little bit better, which ones can do more and which ones can do less. But yeah, as a general rule, we did it slowly as well. You have to earn your right, is how Graham Sate always says it.
Do what you're comfortable with, and yeah, put in some trials.
Alex, do you want to say a little bit about soil tests and maybe the difference between conventional soil test and something like the Haney soil test?
Well, you know more about them than me, I would say,
but from your perspective.
Yeah. So for us, we always do soil tests now, and then we also do tissue or sap analysis so that we actually can compare what our soil has, but what also the plant is actually able to take up and what its shortages might be. And we've done that now for a few years. So it's hard to always respond to that with a full year, but I think the better way to go about it is to use it as a general guide and get an indication of what your soil is actually giving your plants. And then you can change your fertility program a little bit based on that. And then the Haney test, I found really the coolest part about it is when we did on our General Mills project now, a comparison to a side-by-side with the field right beside it, over the last 3 years of no tillage with some cover crops and some diversity, that nothing has fundamentally changed in terms of available phosphate or anything like that. Soil organic matter hasn't really changed, but we saw a huge difference in active active carbon. So I guess there's a lot more microbial activity in those CO2 bursts. So that is really positive. And because that change we would have not been able to see without the Haney test. Like you could visually, to a certain extent, see it maybe with some water infiltration tests and stuff like that. But yeah, that at least kind of confirmed some things for us and gave us more confidence going forward.
Yeah, what you're talking about is the that active fraction of soil carbon that is like the food that feeds the soil biology to do all the good work, to build the aggregation that increases, water infiltration and helps you to earn the right to start doing things like, zero till. Question about compost. Alex, are you making your own compost is the question.
No, it's being made from potato waste from Simplot mixed together with straw. And we are buying it from a composting facility just west of Portage.
Question about Austrian winter peas. Are you using them as green fertilizer? Not harvesting them is what I think she's asking.
Yeah. So, well, we've harvested them as well. Actually, the pea oats mix was with Austrian winter peas. But yeah, our goal was to grow seed for ourselves, and then we use it as cover crop in the fall because we thought it might be because apparently it can take more frost than a regular yellow pea could, or a forage pea. So we thought it could be a good combination to put into cover crops, fall seeded cover crops.
Yeah, I think my limited knowledge on Austrian winter pea is through your farm, and seems like they have, has great potential. It's a winter pea in Austria, of course, right? But here, not so much, though I have seen them over winter on a farm that had really good snow cover and stubble, had that nice warm blanket of snow they did over winter. So there is maybe some possibility there. But what you're saying is if you plant them with oats in the spring, you can harvest Austrian winter peas in the fall.
Yeah, and actually the maturity matches up better than a yellow pea would, because it is a slightly later maturity than a yellow pea is.
Right.
It doesn't
There is
need
some,
wise.
yeah, there is some potential there if we could, just like we have winter wheat and fall rye and winter triticale, the winter cereals, it sure would be nice to be able to have like a Manitoba winter pea. So that's a project for someone to take on. Well, that's it for questions. If nothing else, Dan, just like to thank Darren and Alex. Those were excellent presentations. Really appreciate your time to do that. And I hope this was interesting for the producers on the call and for anyone who was on the call, that they'll take some good ideas back to their farm and think about implementing a few, start small, get comfortable with these new concepts, and there are people out there that can help you. So we're always, Blaine and I and Alex, Darren, we have a number of producers that are basically the experts in this now. They have years of experience and knowledge. So we're here to help out as best we can. So please, give us a call. With that, Dan.
Gotcha. Thanks, Michael. And yeah, just to wrap up today's workshop, a huge thank you to Michael and Blaine for moderating and giving that presentation on regenerative principles, and to Alex and Darren for their great firsthand experiences with regenerative agriculture and the practices. Those are great hands-on stories that was what we want to share, and what these workshops are meant to do, to share those experiences. The engagement today has been great. Lots of great questions, lots of great answers. And I think that'll only lead to further positive engagement and advancement, and the advancement of regenerative agriculture practices in Manitoba and Saskatchewan. I would also like to thank, as we're closing up here, the other partners in Living Labs, Eastern Prairies, Agriculture and Agri-Food Canada, Nature Conservancy of Canada, the International Institute for Sustainable Development, and the 4 watershed districts that are involved with Living Labs Eastern Prairies: the Assiniboine West Watershed District, the Pembina Valley Watershed District, the Red Boyne Watershed District, and the St. Rosa Watershed District. All great partners with great landowners participating in Living Labs Eastern Prairies, and the projects, the regenerative agriculture projects that are going on in there. My apologies again for anybody that had any registration issues today. We're going to work on a couple of little bugs over the next day or two and ahead of Wednesdays, and we'll be sending out reminders that have the links in them versus the link getting buried in the original registration confirmation email. So we'll be working on that to make sure it's all nice and clean for Wednesday as well. I welcome you all back to coming on Wednesday, where Michael and Blaine will be talking about cows and grass and the regenerative agricultural principles involved with in the pasture environment. So they'll be joined by two other producers, Cameron Hodgins and Larry Wegner, for those discussions. So all the registrations are open again on our website. So please go and register if you haven't, or get other people to register as well. And we'll be sending out reminders. And one last thing, Ma will be sending out a follow-up email for all the attendees of this workshop with a link to the video, as well as link to some presentations and contact information of the gentlemen who have presented today. Because like they said, that being experts in the field and being able to answer questions for people that are looking to get into regenerative agriculture is a big part of this, and they're great participants and willing participants to get that knowledge out. So Ma will send a follow-up email to everyone in the days to come following this workshop. So with that said, I don't know, Michael, if you have anything else you wanted to add, but I think we're good for today and this workshop.
Yeah, thanks a lot, Dan. Thanks, everyone. Thanks,
Thank you,
Blaine,
everyone. Have a
Darren,
great
Alex.
day.
All right, thanks. Bye.